Modern industries have to manage complex operational systems such as their supply chain, production systems, distribution systems, customer operations, maintenance systems, etc., taking into account economic, political, social, technological, legal and environmental issues from a tactical and strategic point of view. In such complex environments, being able to make the right operational and strategic industrial decisions becomes key. The solution we offer: Systemic digital twins. All existing digital twin technologies offered by the market focus either on data-related infrastructures or on geometric representations. We believe that this is not the right point of view and that it is necessary to focus on the business processes of the company. A digital twin must indeed be able to model and simulate the behavior of a company, starting from operational data and ending with the enrichment of decision-making dashboards or geometric models, which places business models at the heart of a digital twin. This is why we have adopted a behavioral enterprise architecture approach, based on formal modeling to support simulation by design, which is our key difference from existing digital twin technology. To deal with business complexity, our approach is based on a unified systemic business view that can support operational and strategic analyses. A company must here be considered as a whole within its external environment as a single integrated system which must be, in the most realistic way possible, modeled and simulated by integrating in a coherent way many specialized realistic models. To support our vision, we have developed the patented World Lab technology, based on the proven infrastructure of the Alta-Reka security and reliability analysis tool, developed over the last 20 years and used operationally in many industrial sectors, which is a systems intelligence workshop that provides companies with capabilities in systems analysis modeling and stochastic scenario simulation and evaluation. In particular, World Lab technology makes it possible to automatically produce systemic digital twins from a high-level specification designed in our formal modeling language Sigma. These systemic digital twins will then be accessible in software mode as a service or via local deployment on our client servers, if necessary, for example for data privacy issues. To illustrate this, here is an application case: underwater mining. How it works: polymetallic nodules are collected from the seabed by a seabed mining tool. They are then sent aboard a mining support vessel by a lifting system. On board the support vessel, they are dried and then transferred to a bulk vessel. The bulk vessel travels from the port to the mine site and returns to the port to transport the nodules, which are then unloaded in the port. The goal, the very first step, is to clarify the business problem to be solved. Here, to minimize the duration of use of the bulk vessel. Let us now see how to build a systemic digital twin for this underwater mining case study. In this matter, we shall start with a modeling activity carried out with the SESAM model-based systems engineering framework. We shall then first identify the world, that is to say the perimeter of interest, to be considered, which consists in the system of interest, our underwater mine system, broken down into subsystems and of the relevant external systems within its environment. And then to define the business processes and rules that are associated with the different systems involved in our world. The second step consists now in the development of the Sigma model. We will now see an example concerning the generation of the systemic digital twin. Thanks to the WordLab platform, we can now automatically generate the systemic digital twin that simulates the previous Sigma model. When building the digital twin, we can manage a number of parameters like the capacity of the bulk carrier, its speed, the distance to the port, etc. We can now simulate the behavior of our underwater mine and of its environment. Each step simulates here 1 hour of evolution of the sea and of the different systems forming the sea mining system. We can also handle global stochastic simulations, either when building the digital twin or when the digital twin is in run mode. In the example here, we are simulating the behavior of the underwater mine for 1 month, then for 2 months. These simulations allow typically to provide estimations for a number of business indicators such as, here, the level of nodules produced by the underwater mine during a certain period of time. We can then solve our initial problem, that is to say optimizing the use of the bulk vessel, by analyzing the durations that the bulk vessel passes in the sea, on site and in the harbor, as provided by our systemic digital twin. For more information, do not hesitate to contact us. Thank you.